For thousands of years we looked up at it and saw paradise. We named it after the goddess of love. We dreamed of its tropical oceans, but we were wrong. This is not paradise. This is the most terrifying place in the solar system, a world where the rain is sulfuric acid, where the air will crush you like a tin can, where the temperature melts lead in seconds, and yet we dared to go down there. This is the story of how humanity sent robots into hell, and what they saw there before they died. There is a light in the sky that has deceived us for 10,000 years. If you walk out into a field just after sunset, when the twilight is bleeding from purple into black, you will see it. It hangs low on the western horizon. It is not a star. It does not twinkle. It burns with a steady, piercing white brilliance that outshines everything else in the heavens. The ancient Sumerians saw it and called it Inanna, the Queen of Heaven. The Mayans built entire stone observatories just to track its movements through the jungle canopy. The Romans, captivated by its pure, jewel-like beauty, named it after their goddess of love, Venus. For millennia, we looked at this wandering light and felt peace. We felt hope. We projected our deepest romantic fantasies onto that blank white canvas. We called it the morning star and the evening star. We believed it was a twin to our Earth, a sister world, almost the same size, almost the same gravity, tucked safely under a blanket of white clouds. In the late 19th and early 20th centuries, as telescopes improved, astronomers gazed at Venus and saw nothing. The planet was shy. It refused to show its face. It was wrapped in a thick, impenetrable layer of clouds that reflected the sunlight with blinding intensity. And because we could not see, we dreamed. Science fiction writers and serious scientists alike looked at those clouds and made a logical assumption. Clouds mean water. Water means rain. Rain means life. They imagined a world of eternal twilight. They pictured vast, steaming oceans that covered the entire globe. They imagined swamps the size of continents filled with giant ferns and prehistoric jungles. They dreamed of a younger Earth, a humid tropical paradise where dinosaurs might still roam, where the rain never stopped, and where the air was thick with oxygen and the smell of wet soil. It was a beautiful dream. It was a comforting dream. It was also the greatest lie the solar system has, because beneath those white clouds, there is no water. There are no dinosaurs. There is only a horror beyond human comprehension. If you were to stand on the surface of Venus today, you would not be standing in a swamp. You would be standing in an oven. The temperature is 475 degrees Celsius. That is 900 degrees Fahrenheit. It is hotter than the surface of Mercury. It is hot enough to melt lead. It is hot enough to set a block of wood on fire instantly, not with a flame, but by the sheer heat of the air itself. But the heat is the least of your problems. The air itself is a weapon. The atmosphere is 92 times heavier than the atmosphere of Earth. Standing on the surface would feel like being crushed by a kilometer of ocean water. The air is so thick it is no longer a gas. It is a supercritical fluid. It moves like molasses. It creates a pressure that would crush a submarine. And the clouds, those beautiful white clouds that we admired from Earth, they are not made of water. They are made of concentrated sulfuric acid. It rains battery acid on Venus. But the ground is so hot that the rain evaporates before it ever touches the rocks, creating a cycle of chemical torture that has lasted for hundreds of millions of years. There is no day and no night. The sky is a glowing, sickly vault of sulfur yellow light that never changes, never dims, and never reveals the sun. This is not the goddess of love. This is the goddess of hell. But we didn't know that. Not yet. To find out the truth, we had to go there. We had to build ship. We had to hurl metal and silicon into the fire. This is the story of the longest, hardest, and most tragic siege in the history of space exploration. This is the story of the Soviet Venera program. It is a story of and it begins not with a launch, but with a whisper of radio static in the Cold War silence of 1961. The year is 1961. The world is divided by an iron curtain. Two superpowers, the United States and the Soviet Union, are locked in a technological duel for the high ground of space. Yuri Gagarin has just flown. The Soviets are drunk. They have beaten the Americans to orbit. Now they want the planet at a secret facility near Moscow known only as OKB. 1. The legendary chief designer Sergei Korolev gathers his team. These are men who work in the shadows. Their names are state secrets. They work in smoke-filled rooms, drinking stale coffee, calculating trajectories with slide rules and pencils. They set their sights on Venus, but they are building their ships based on the dream, not the reality. They equipped their first probes with sensors to detect water. They designed them to float. They were building boats to sail on lava, though they didn't know it yet. The first attempts were heartbreaking. Venera 1 launched in February 1961. It was a masterpiece of Art Deco engineering, a silver cylinder with gold solar panels. It slipped the bonds of Earth. It headed for the morning star. But 7 days later, millions of miles from home, its radio overheated. It fell silent. It became a ghost ship, drifting past Venus, mute and blind. Then came the Americans. In 1962, NASA launched Mariner 2. The Americans were caught. They didn't try to land. They knew they weren't ready. They planned a flyby, a quick sprint past the planet to scan it from a safe distance. On December 14, 1962, Mariner 2 skimmed past Venus at a distance of 34,000 kilometers. It aimed its microwave radiometers at the dark side of the planet. It pierced the clouds. The data streamed back to Earth. It was a series of numbers, binary code on magnetic tape. When the scientists decoded it, they didn't believe it. They checked the math. They checked the instruments. The code said, temperature 400 degrees Celsius. The dream of the jungle died in that moment. The newspapers ran the headlines, Venus is a dead world. Venus is a furnace. Most rational people would have stopped there. Why go to a hellhole? Why spend billions of rubles or dollars to land on a planet where nothing can live? But the Soviets were not rational. They were stubborn, and they needed a victory. They decided that if Venus was hell, they would build demons to conquer it. They handed the project to a new design bureau, the Lavochkin Association, led by a brilliant obsessive engineer named Georgy Babakin. Babakin looked at the Mariner data. He saw the heat. He saw the impossible odds, and he said, "We will land." How do you build a machine to survive the apocalypse? You start by watching your creations get destroyed one by one. Between 1963 and 1967, the Soviet Union launched a fleet of ships, Venera 2, Venera 3, Cosmos 96. They were martyrs. Venera 3 became the first human object to physically touch another planet on March 1, 1966. But it didn't land. It crashed. The communication system failed before it hit the atmosphere. It smashed into the night side of Venus, a piece of twisted metal buried in the dark. It was a symbolic victory, but a scientific failure. Then came 1967, the year of Venera 4. This was the mission that would taste the fear. Georgy Babakin and his team redesigned the lander. They knew it was hot, but they didn't know how dense the air was. They guessed the pressure might be 10 or 20 times that of Earth. They built a sphere, a 1-meter wide ball made of aluminum alloy. They packed it with sugar. Yes, sugar, which acted as a rigid insulator that would melt away. They coated it in an ablative heat shield, a thick layer of honeycomb material designed to burn off during entry. On October the 18th, 1967, Venera 4 arrived at the gates of hell. It hit the top of the atmosphere at 11 kilometers per second. That is 24,000 miles per hour. The shockwave was instantaneous. The temperature on the heat shield spiked to 11,000 degrees, hotter than the surface of the sun. The G-forces peaked at 300 Gs. A human would be turned into soup. The electronics screamed, but the sphere held. It slowed down. The braking parachute deployed. The sphere separated from the bus. The antenna unfolded. And then the transmission began. For the first time in history, we were hearing the voice of a machine descending into the atmosphere of another world. In the control room in Crimea, the pens on the chart recorders began to scribble frantically. Temperature, 40 degrees, 50 degrees, 80 degrees. Pressure, 1 atmosphere, 2 atmospheres, 5 atmospheres. The probe was falling slowly, swinging under its parachute. But as it fell deeper, the news got worse. The temperature wasn't leveling off. It was skyrocketing. At 20 kilometers down, it was 200 degrees. The pressure was climbing past 10 atmospheres. The scientists watched the altimeter, the radar measuring the distance to the ground. It read, altitude 28 kilometers. They were confused. The pressure was already crushing. How could they still be 28 kilometers high? The answer was a terrifying realization. The atmosphere was much, much deeper than anyone had predicted. The ground Mariner 2 had seen wasn't the ground. It was just a layer of super-dense gas. The real surface was miles further down, deep in the crushing dark. Venera 4 was not built for this. At an altitude of 27 kilometers, the pressure hit 18 atmospheres. The aluminum hull began to groan. Imagine a submarine diving too deep. The metal plates buckle, the rivets pop, the seams scream. The telemetry signal became erratic. Snap. Silence. Venera 4 had been crushed like an eggshell. It was imploded by the sheer weight of the sky. It never saw the ground. It died in mid-air, miles above the surface, its debris raining down into the acid clouds. But it had sent a message before it died. It told the engineers, "You need to be stronger." The failure of Venera 4 stung, but it provided the numbers. Now Babakin knew. The pressure wasn't 20 atmospheres, it was closer to 90. To survive that, you don't build a spaceship. You build a deep-sea diving bell. There was no time to completely redesign the next probes, Venera 5 and 6, which were already being built. They reinforced them as best they could, but they knew it wouldn't be enough. In May 1969, Venera 5 and 6 arrived. They dove into the atmosphere. They fought bravely. They made it deeper than Venera 4, down to 18 kilometers. But the result was the same. Implosion. Crushed. 2 more metal skeletons added to the graveyard. But back in Moscow, in the high-security workshops of the Lavochkin Bureau, something new was taking shape. Venera 7. This was a monster. The engineers stopped caring about weight. They stopped caring about elegance. They cast the pressure vessel out of titanium. Titanium is it is stubborn, but it is strong. They made the walls thick. They limited the internal space until it was just a tiny, cramped sphere packed solid with instruments. There was no room for air. They lined the inside with shock absorbers. They removed the glass windows. Glass is a weak point. There would be no cameras on Venera 7, no pictures. The goal was singular: survival. They tested it in massive pressure chambers on Earth. They subjected it to 150 atmospheres. They baked it in ovens. They dropped it from planes to test the shock resistance. It was a cannonball designed to fall into hell. They launched it on August 17th, 1970. It traveled the void for 4 months. On December 15th, 1970, Venera 7 arrived. The descent of Venera 7 was a horror movie played out in telemetry data. It hit the atmosphere, the heat shield burned away, the parachute deployed. But this time the parachute was different. The engineers knew that a large parachute was a death sentence. It kept the probe in the air too long, letting the heat cook the electronics. So they designed a reefed parachute. It would open only partially at first, letting the probe drop fast through the upper clouds, and then open fully lower down. The probe plummeted. It screamed through the acid layer. It passed the 28-kilometer mark where Venera 4 had died. It kept going. It passed the 18-kilometer mark where Venera 5 and 6 had died. It kept going. The temperature outside rose to 300 degrees, then 400. The titanium hull was glowing dull red in the darkness of the infrared spectrum. Inside, the cooling system was fighting a losing battle. The electronics were sweating. Then disaster struck. At an altitude of 4 kilometers, the parachute failed. Maybe the cords melted, maybe the fabric disintegrated in the 450-degree heat, or maybe the sheer turbulence of the atmosphere ripped it. The parachute vanished. Venera 7 began to freefall. It was a 4-kilometer drop onto solid rock. Imagine dropping a washing machine from an airplane. It fell through the soup-thick air. The air resistance slowed it down somewhat, but it was still moving at 17 meters per second, about 38 miles per hour. In the control room on Earth, the signal was strong. Then, impact. The line on the screen went flat. Silence. The engineers put their heads in their hands. Another failure. It had crashed. The impact must have shattered the electronics. For an hour, they sat in the gloom of the control center, processing the loss. They began to write the press release for a partial success. But one man, a telemetry expert, wasn't satisfied. He was staring at the raw signal feed coming from the massive radio dish. The main data stream was dead, but in the background noise and the static of the cosmos, there was a shadow, a faint, rhythmic pulse. It was barely there. It was a whisper in a hurricane. He applied a digital filter, he boosted the game, and there it was. Code. Temperature data. The probe wasn't dead. Venera 7 had survived the fall. It had hit the ground with the force of a car crash, bounced and rolled onto its side. The antenna was misaligned. It wasn't pointing at Earth. It was pointing sideways. That's why the signal was so weak. But the titanium heart was still beating. For 23 minutes, Venera 7 sat on the surface of Venus. It was the first time in the history of the universe that an object made by human hands had transmitted from the surface of another planet. It was sending back the news from hell. Temperature, 475 degrees Celsius. Pressure, 90 atmospheres. Surface, solid. Think about that environment. It is dark, but not black. The sky glows with a diffused angry orange light, like the embers of a dying fire. The air is so thick it distorts sounds. A whisper would sound like the wind pushes against the lander with the force of a slow-moving river, and it's so incredibly hot. The solder joints inside the probe began to melt. The wires began to fuse. After 23 minutes, the internal temperature became too high. The electronic brain cooked. Venera 7 sent one last pulse and then died. It is still there today, a melted titanium monument resting on its side in the dark, the first conqueror of the planet of no return. But Venera 7 was blind. It told us what Venus was, but it didn't show us. We knew the numbers. Now we needed the image. We needed to see the face of the beast. But putting a camera on that was considered impossible. How do you make a window that doesn't melt? How do you make a lens that doesn't crack? The engineers at Lavoch, they were about to enter the golden age of the Venera program. They were about to build the photographers. Venera 9. The year is 1975. The Cold War has shifted. The moon race is over. The Americans won the sprint. But the marathon of the planets is just beginning. In the high-security workshops of the Lavochkin Association outside Moscow, the Soviet engineers are looking at a problem that defies physics. They have proven they can land. Venera 7 survived for 23 minutes. Venera 8 survived for 50 minutes. But survival is not enough. The Kremlin wants a picture. They want to see the face of the enemy. They want to put a camera on the surface of Venus. Consider the madness of this request. To take a photo, you need lenses are made of glass. But on Venus, the thermal shock of landing, going from the freezing cold of space to 475 degrees Celsius in minutes, would shatter standard glass like a bomb going off. You need film or a sensor, but at 475 degrees, celluloid melts instantly. Electronic sensors turn into useless static. You need a window. But the pressure is 90 atmospheres. A window is a weak point. If it cracks, the pressure will force the acid atmosphere inside, instantly incinerating the delicate electronics. And you need light. The scientists were convinced that beneath the thick clouds, Venus was pitch black. They thought it would be like the bottom of the ocean, an eternal ink-black night. To take a picture, they thought they would need massive floodlights. So, how do you build a photographer for hell? The engineers, led by the brilliant designer Vladimir Perminov, came up with a solution that was pure steampunk genius. They realized they couldn't put the camera outside. It would die instantly. So, they hid it. They placed the camera mechanism deep inside the spherical pressure vessel, wrapped in layers of insulation, submerged in the cooling system. To see out, they built a periscope, a thick steel tube that poked out through the hull. Inside the tube, they placed a system of prisms and mirrors to bounce the light down into the safe zone. But what about the window? They couldn't use normal glass. Instead, they used quartz and industrial diamond, coated in gold to seal the microscopic gaps between the window and the steel frame. They didn't use a digital shutter. They used a telephotometer, a mechanical scanner. It worked like an old fax machine. A single sensor would look through the periscope and a mirror would mechanically tilt, scanning the landscape line by line, pixel by pixel. It was slow, it was primitive, but it was robust. To keep the lander cool, they invented a thermal battery. They filled the interior of the probe with a chemical salt, lithium nitrate trihydrate. This salt melts at exactly 30 degrees Celsius. The laws of thermodynamics state that when a substance melts, it absorbs heat without rising in temperature, so as the heat of Venus attacked the lander, the salt would sacrifice itself. It would melt, absorbing the deadly energy, keeping the camera cool for just long enough. It was a suicide machine. It had a lifespan measured in minutes. They built two of these monsters, Venera 9, Venera 10. They were 5 tons of metal, ambition, and Soviet pride. They launched in June 1975. They traveled for 4 months through the dark. On October 22nd, 1975, Venera 9 arrived. The descent of Venera 9 was different. The engineers had learned from the previous failures. They knew that a parachute was a liability. The atmosphere of Venus is so thick that a parachute acts like a sail, keeping the probe suspended in the hot upper air for too long. They needed to drop fast. They needed to race the heat. So they changed the design. Venera 9 used a series of pilot chutes to slow down initially, but at an altitude of 50 kilometers, while still high in the cloud deck, it did something radical. It cut the parachute. It fell. It didn't plummet like a stone, though. It had a rigid metal ring around the top of the lander, an aero brake. Because the air on Venus is a supercritical fluid, it acts more like water than air. The metal ring created drag, stabilizing the lander. Venera 9 sank through the sky like a diving bell sinking into the ocean. It passed the acid clouds. It passed the crushing depths where Venera 4 had died. It passed the 4-kilometer mark where Venera 7's parachute had failed. The floodlights turned on. The engineers were terrified of the dark, but as it dropped below 10 kilometers, the sensors picked up a glow. It wasn't dark. The thick atmosphere scattered the sunlight, diffusing it like a lamp behind a heavy curtain. The sky was glowing. Thump. Venera 9 hit the ground at 7 meters per second. The shock absorbers compressed. The lander settled on a 20-degree slope. It was alive. Eject lens caps, the computer commanded. This was the most critical moment. The windows were protected by heavy metal covers during the descent. If they didn't pop off, the mission was blind. Bang! The pyrotechnic bolts fired. The telemetry confirmed lens cap 1 ejected, but lens cap 2 failed. It stayed stuck. Venera 9 was a cyclops. It could only see in one direction, but one direction was enough. The mechanical scanner began to move. Back on Earth, at the deep space antenna in Yevpatoria, the signal arrived. It was a slow, agonizing process. The image built up on the thermal paper, one line at a time. First, just noise. Then, a jagged line, the horizon. Then, shapes. The scientists gathered around the printer. They were expecting sand. They were expecting a smooth, eroded desert, worn down by the crushing pressure. Instead, they saw chaos. The image revealed a field of sharp, angular rocks. They looked like broken concrete slabs. They were not eroded. They were fresh. This meant that Venus was geologically active. Something was breaking. Earthquakes, landslides, and the shadows. There were distinct shadows. This proved that the light wasn't just a murky gloom. It was directional. The sun was somewhere up there, hidden behind miles of acid fog. For 53 minutes, Venera 9 sat on that slope and beamed back the picture of a nightmare. It was a landscape of absolute desolation. No trees, no movement, just sharp gray rocks baking in the oven. Then the lithium salts melted completely. The internal temperature, the radio drifted off frequency, the signal died. 3 days later, Venera 10 landed. It landed on a flat plain of lava rock, miles away. It too successfully ejected one lens cap and failed to eject the other. The lens cap curse was real, but it confirmed the discovery. Venus was a world of rock and hard surfaces. The Soviet Union released the images to the world. They were grainy. They were black and white. They were distorted. But they were real. Humanity had stared the goddess in the face, and she was made of stone. But black and white wasn't enough. The scientists looked at the gray rocks and asked, "What color is it? Is it red like Mars? Is it gray like the moon?" They needed color, and they needed sound. They needed the masterpieces. It took 7 years to build the next generation. Venera 13 and Venera 14 were the pinnacle of Soviet robotic engineering. They launched in 1981, They were identical twins sent to They carried advanced color cameras. They carried drills to bore it, and for the first time they carried microphones. March 1st, 1982. Venera 13 arrives. The descent is perfect. The aero brake works. The lander touches down in a region called Phoebe Regio. Impact. The first thing Venera 13 did was listen. The microphone turned on, the recording was sent back to Earth. If you listen to it today, it sends shivers down your spine. First, you hear the mechanical clunk of the lander settling, then you hear the wind. It is not the whistling wind of Earth. It is a low, deep, acoustic rumble. It sounds like a giant breathing. Because the air is so dense, it travels faster and carries more energy. A whisper on Venus would hit your eardrums like a shout. The wind, moving at only 1 meter per second, sounds like a freight train. It is the sound of a dead world talking to itself. Then, the cameras started. The color wheel spun. Red filter, green filter, blue filter. The data came back. The scientists combined the channels, and the screen filled with color. Orange. Everything was orange. The sky was a brilliant, sickly apricot color. The ground was brownish orange. The rocks were orange. The atmosphere of Venus is so thick that it filters out almost all blue light. If you were standing there, you would be colorblind to blue. The white metal of the lander looked yellow. The blue paint on the color calibration strip looked black. It was a monochromatic hellscape, a world trapped in eternal sunset. Venera 13 was a champion. It was designed to survive for 32 minutes. It lived for 127 minutes. For over 2 hours, it sat in the fire. It drilled into the rock, a feat of incredible engineering, drilling in 475-degree heat without the lubricant boiling away. It analyzed it found thinking rocks, highly alkaline basalts. It sent back a panoramic view that remains the sharpest, most detailed image of Venus we have to this day. But its twin, Venera 14, was destined for a tragic comedy. Venera 14 landed 4 days later, on March 5th, 1982. It landed in a fascinating area, a landscape of cracked flat plates that looked like a giant paved parking lot. The computer went through its checklist. Eject lens caps. Bang. This time, the engineers had upgraded the pyrotechnics. Both lens caps popped off perfectly. The front camera saw the horizon, the rear camera saw the landscape. Success. Then came the next command. Deploy compressibility tester. This was a spring-loaded arm tipped with a hammer. It was designed to swing down, strike the rock, and measure how hard the ground was. The arm swung down. Clang. The telemetry came back. The arm had fully extended. It had struck something hard. But the data was weird. The rock was metallic. It was too hard. The scientists looked at the photos from the rear camera. They zoomed in on the spot where the hammer had struck. There, lying perfectly on the rock, right under the hammer, was a circular, semicircular piece of titanium. It was the lens cap. The lens cap had popped off, tumbled through the air, and rolled exactly to the millimeter into the spot where the arm was programmed to strike. Venera 14 had traveled 40 million kilometers. It had survived the vacuum. It had survived the re-entry. It had survived the crushing pressure. And in the end, it deployed its scientific instrument to measure the hardness of its own lens cap. It was a cosmic joke. The universe was laughing at us. It was saying, "You can come here, little humans. You can bring your titanium toys, but I will still make you look foolish." Venera 14 died after 57 minutes. Its mission technically a success, but forever marred by that one unlucky roll of a metal disc. The Soviets weren't done. They knew they couldn't survive on the surface for long. The heat always won. So they decided to try a different approach. If the ground is hell, maybe the sky is purgatory. In 1985, they launched the Vega missions. Vega 1 and Vega 2. These were motherships designed to go to Halley's Comet. But on the way, they dropped off passengers at Venus. Landers, yes, but also balloons. Imagine a balloon, 3 meters wide, filled with helium. It was dropped into the night side of Venus. At an altitude of 54 kilometers, the balloon inflated. Here, the conditions were surprisingly Earth-like. The temperature was about 30 degrees Celsius. The pressure was half an atmosphere. If you had an acid-proof suit and an oxygen mask, you could float here. You wouldn't be crushed. You wouldn't burn. The Vega balloons drifted in the darkness, but they didn't drift calmly. They were caught in the superrotation. The atmosphere of Venus spins incredibly fast. While the planet takes 243 Earth days to rotate once on its axis, the clouds whip around the planet in just 4 days. The winds were blowing at 250 kilometers per hour. The balloons were tossed like leaves in a hurricane. They bobbed up and down. They measured lightning flashes, continual, strobe light lightning illuminating the dark clouds. They detected turbulence that would rip a modern airplane apart. They survived for 2 days, traversing a third of the planet, sending back data about the chaotic weather of the upper atmosphere. They were the last Soviet machines to touch the atmosphere. In 1989, the Soviet Union began to collapse. The rubles dried up. The great design bureaus fell into disrepair. The Venera program ended. Since 1985, no lander has touched the surface of Venus. The Venera robots, 7, 8, 9, 10, 11, 12, 13, 14, are still there. They are sitting in the dark. They are not rusting because there is no oxygen and no water, but they are changing. The lead solder has melted and refrozen into the aluminum components have likely softened and deformed. The lenses of the cameras are probably etched by the acid vapor, but the titanium pressure vessels, the skeletons, they sit in the eternal orange gloom, statues of a fallen empire, waiting for the next visitor. But while the landers slept, a new visitor arrived, an American. And it didn't want to land. It wanted to see through the clothes of the goddess. It wanted to see this. By the late 1980s, the Soviet invasion of Venus was over. The titanium landers were silent monuments on the surface, slowly cooking in the gloom. We knew what the ground looked like in a few specific spots. We had the orange photos from Phoebe Regio and the grey photos from Beta Regio, but we were still missing the big picture. We knew the skin of the beast, but we didn't know its skeleton. Because of the clouds, we couldn't see the geography. We didn't know if Venus had continents. We didn't know if it had mountain ranges like the Himalayas or trenches like the Mariana. To see through the acid fog, we needed a different kind of eye. We needed a bat. In 1989, NASA launched the space shuttle Atlantis. Inside its cargo bay sat a machine called Magellan. Magellan was not a photographer, it was a radar mapper. It arrived at Venus in August 1990. It entered a polar orbit, looping over the planet from north to south. Every orbit it turned its massive dish toward the clouds and screamed. It fired bursts of radio waves down through the haze. The waves hit the ground, bounced off the rocks, and returned to the spacecraft. Magellan listened to the echo. If the surface was rough, the echo was bright. If the surface was smooth, the echo was dark. By measuring the time it took for the echo to return, it built a topographic map. For 4 years, Magellan stripped the goddess naked. It mapped 98% of the surface, and as the data was processed at the Jet Propulsion Laboratory, a new world emerged on the computer screens. It was not the swampy paradise of the 1920s. It was not the boring desert of early theories. It was a planet of scars. It was a planet that looked like it had been ripped apart and glued back together by a madman. What Magellan saw was a landscape dominated by one thing: fire. Venus is the volcano capital of the solar system. The radar maps revealed more than 1,600 major volcanoes and hundreds of thousands of smaller ones. There is Mont Mons, a giant shield volcano standing 8 kilometers high, higher than Mount Everest is above sea level. It sits there, silent and massive, covered in black lava flows that stretch for hundreds of miles. There are pancake domes, strange, flat-topped hills that look exactly like pancakes on a griddle. These were formed by thick, sticky lava oozing out of a vent and cooling instantly in the crushing pressure, unable to flow away. There are arachnoids, features unique to Venus. They look like spider webs cracked into the crust. They are vast networks of fractures where the ground has been pushed up by magma from below, cracking the surface like the shell of a hard-boiled egg. And there are the Baltis Vallis, rivers of lava. One of them is nearly 7,000 kilometers long. That is longer than the Nile River on Earth. Imagine a river of molten rock flowing across an entire continent, never cooling, never stopping, burning a channel into the bedrock. But the most terrifying discovery wasn't what was there. It was what was missing: craters. Look at the Moon, look at Mars, look at Mercury. They are pockmarked with holes. They are records of cosmic They bear the scars of the late heavy bombardment from 4 billion years ago. Venus should be the same. It is right next door. But when the geologists looked at the Magellan maps, they were baffled. There were very few craters on Venus, only about 1,000, and they were randomly distributed. There were no old craters, no ancient basins. The surface looked young. They calculated the age. The surface of Venus is estimated to be only 300 to 500 million years old. That the planet is 4.5 billion years old. Where is the first 4 billion years of history? Where did the old craters go? The answer is a theory that sounds like a planetary horror story. It is called the global resurfacing event. On Earth, we have plate tectonics. The crust is broken into puzzle pieces that move. Heat escapes through the cracks at the edges of the plates, through volcanoes, through earthquakes. It is a continuous, slow release valve. Venus does not have plate tectonics. Its crust is one solid, thick lid. The heat inside the core has nowhere to go, so it builds up. Radioactive decay in the core. The mantle gets hotter, the pressure builds, the magma swells. For hundreds of millions of years, the planet holds its breath, and then it explodes. The theory suggests that every 500 million years or so, the entire crust of Venus becomes unstable. It subducts, it melts, it sinks into the mantle. The whole planet turns itself inside out. Millions of volcanoes erupt simultaneously. The surface becomes a global ocean of lava. Every crater, every mountain, every ancient rock is melted down and erased. The slate is wiped clean. Then the planet cools. The lava freezes into a new solid shell, and the cycle begins again. We believe the last time this happened was about 500 million years ago, which means Venus is currently in the quiet phase. It is building up pressure. It is a ticking time bomb. It reminds us that a planet is not a dead rock. It is a living engine, and Venus is an engine that runs on a cycle of catastrophic destruction. Why do we study this hellscape? Why spend billions to map a planet we can never colonize? Because Venus scares us, or at least it should. Venus is the Earth's evil twin. They were born in the same cloud of gas and dust. They formed at they have roughly the same radius. They have roughly the same density. Billions of years ago, when the sun was dimmer, Venus might have been a blue world. Computer models suggest that ancient Venus had shallow liquid water oceans. It might have had a temperate climate. It might have had blue skies. It might have been habitable. But something went wrong. Venus is 30% closer to the sun than Earth. As the sun aged, it got brighter. The temperature on Venus rose slightly. The water in the oceans began to evaporate. Water vapor is a powerful greenhouse gas. It traps heat. The more water evaporated, the hotter the air got. The hotter the air got, the more water evaporated. It was a feedback loop, a runaway train. Eventually, the oceans boiled dry. The water vapor floated into the upper atmosphere, where ultraviolet light from the sun split the H2O molecules apart. The hydrogen escaped into space. The oxygen bonded with carbon. At the same time, because there was no water to lubricate the tectonic plates, the crust locked up. The carbon cycle stopped. On Earth, rocks absorb carbon dioxide. Rain washes it, gets buried in the ocean floor. On Venus, the carbon had nowhere to go but the atmosphere. The volcanoes pumped out CO2. The baking rocks released CO2. The atmosphere became a heavy blanket of heat-trapping gas. Today, the atmosphere is 96% carbon dioxide. The result is a temperature of 475 degrees. Venus is a warning. It is a laboratory demonstration of the greenhouse effect taken to its absolute apocalyptic extreme. When we look at Venus, we are looking at what happens to an Earth-like planet when the climate control system breaks. We are looking at our own potential future viewed through a distorted, nightmarish mirror. For decades, we wrote Venus off as dead. The surface is a sterilizing oven. Nothing organic can survive there. The chemistry is too hostile. But in science, you should never say never. In September 2020, a group of astronomers led by Jane Greaves made an announcement that shook the world. They pointed the James Clerk Maxwell Telescope in Hawaii and the ALMA Array in Chile at Venus. They weren't looking at the ground. They were looking at the clouds. Specifically, they were looking at the temperate zone. At an altitude of 50 to 60 kilometers, the conditions on Venus are, strangely nice. The pressure is 1 atmosphere, same as sea level on Earth. The temperature ranges from 0 to 50 degrees Celsius. If you were floating there in a gondola, you wouldn't need a pressure suit. You would just need an oxygen mask and an acid-proof raincoat. The astronomers analyzed the light passing through these clouds. They were looking for chemical signatures. They found a spectral line that shouldn't be there. Phosphine, pH3. On Earth, phosphine is a nasty, smelly, toxic gas. It is produced by only 2 things: industrial factories making pesticides, specifically anaerobic bacteria living in oxygen-starved environments like swamp mud, sewage, or the guts of penguins. There is no known geological process, no volcano, no lightning strike that can produce phosphine in the quantities they saw on Venus. The implication was staggering. Could there be life on Venus? Not on the surface, but in the clouds. Aerial microbes. Imagine bacteria that live their entire existence drifting in the acid haze. They metabolize sulfur. They reproduce in droplets of liquid. They float on the thermal updrafts, staying forever in the temperate zone, never falling into the fires below. When they die, They fall and burn up. The discovery sparked a firestorm of debate. Other scientists reanalyzed the data. Some said it was an error. Some said it was sulfur dioxide masquerading as phosphine. The jury is still out. The debate is fierce. But the question has reignited our obsession with the morning star. We have realized that we might have been looking for life in the wrong place. We were looking for water on Mars, while the aliens might be floating next door in the clouds. The discovery of phosphine and the realization of how little we know about Venus's geology has triggered a new space race. After 30 years of ignoring the planet, humanity is going back. NASA has selected 2 missions: Da Vinci, Deep Atmosphere, Venus Investigation of Noble Gases, Chemistry and Imaging. It will drop a probe through the atmosphere, sniffing the gas layer by layer, and taking high-resolution photos of the tesserae, the oldest, most rugged highlands on the planet, before it crashes. Veritas, Venus emissivity, radio science, INSAR, topography, and spectroscopy. An orbiter that will map the surface in even higher detail than Magellan, looking for active volcanoes and ground movement. The European Space Agency is sending Envision. India is planning Shukryan-1. A private company, Rocket Lab, is planning a small probe to hunt for the microbes in the clouds. We are arming ourselves with new eyes, new ears, and new noses. We are going back to the planet of no return. We want to know if it really was Earth's twin. We want to know when the ocean. We want to know if the volcanoes are erupting right now, and we want to know if we are alone. As the sun sets on Earth tonight, go outside. Look to the west. In the deepening twilight, you will see it. First, a pinprick, then a diamond. It is the brightest object in the night sky after the moon. It shines with the steady, serene, white light. It is beautiful. It is the definition of celestial calm. Lovers will wish upon it. Sailors will navigate by it. But now you know the truth. You know that beauty is a mask. You know that beneath that white veil lies a world of crushing darkness, orange twilight, and melted metal. You know that down there, on the basalt plains of Phoebe Reggio, sits the crushed titanium skeleton of Venera 13. It sits in the silence beneath the weight of an ocean of carbon dioxide, slowly dissolving in the acid rain that never hits the ground. It is a monument to human curiosity, a monument to the fact that we touched the fire and survived, even if only for an hour. Venus teaches us a hard lesson. It teaches us that the universe is not. It is wild, it is violent, it is indifferent. It teaches us that a planet is a fragile thing, that a blue world can turn into a hellscape if the balance is tipped. So, when you look at that bright point of light, feel the awe, but also feel the gratitude. Take a deep breath of the cool evening air. Feel the gentle wind on your face. Look at the rain falling on the grass. We are the lucky ones. We are the twins who survived. The morning star watches us from the dark, and it whispers, "Take care of your home.